Hello and warm welcome to our today's webinar, The Intelligence Behind Buildings, Build Smarter with Zenon. Together with me today will be my colleague Dan Seršen from our office in Ljubljana in Slovenia. And also I would like to wish a very warm welcome to our guest, Ognjen Lukačević from Elkon company from Podgorica, our silver partner from Coppa partner community. Welcome.
Hello, welcome. Thank you.
Today's agenda, briefly, we will do the short introduction of Exoreti and Coppa companies. Elkon will be presented during the session with the reference, and we will switch to topic of building automation with Zenon. So we will dive into more technical details from Zenon side, and then the main topic today with our guest speaker from Elkon, Zenon in the first next generation private hospital in Montenegro. At the end, we will have a Q&A session. You can post the questions in Q&A. You will see it probably down there in Zoom. And please feel free to post any question and we will try to answer it at the end of this webinar. So let's start with Exoreti profile. So we are providing innovative software and hardware solutions from world-leading companies to our local market. We are present in 8 markets. You can see the companies that we are representing, and we are present in all parts of industries, energy, and infrastructure, which is our today's main topic. As I mentioned, we are present in more than 8 countries in the region. There are 10 brands that we represent, and we have more than 500 customers in our region. We have offices in Slovenia, in Croatia, and in Serbia. Speaking about the Coppa manufacturer of Zenon software, which is our main topic today. So Coppa exists almost 40 years, has more than 500 employees worldwide, has more than 500 members of Coppa partner community, as Elkon is part of this community, and we have more than 30 partners in our region where Exoreti is present. There are more than 300,000 installations of Zenon worldwide. Together with Coppa we are also providing technical support, local technical support, and all kinds of trainings, so you can contact us for this part. Industries, as I mentioned, exactly as Exoreti is covering all industries and energy and infrastructure, Zenon can be connected to all industries, including energy infrastructure, pharmaceutical, food and beverage, and automotive. Today, starting with infrastructure, let's see why this is important. What are the requirements for modern building management system? First, we need to have equipment under control. So all visualization, control parameters, trends, alarms, events, situational awareness is really important. Second, we need to operate building remotely from PC, from smartphone, from tablet, or all types of devices. Third, sustainability. Today, energy management is really important. We can integrate also solar power plants, batteries, control them, and also use electric vehicle chargers. Fourth, integration of diverse hardware and infrastructure. So connectivity, networking, user management, IT security, quick integration, and easy maintenance are really important topics for modern building management system. And the last but not least, automated data acquisition and analysis. We need to communicate with PLCs, with counters, with sensors. We need to contextualize this data, archive, process, and do the reports. All of this we will try to cover in today's webinar through real example that was done recently. So next, first I will again not make a note to post the questions in Q&A that we will answer later. And now the second point of today's webinar, Building Automation with Zenon, will be represented by my colleague, Dejan.
Thank you, Dalibor. Hello to everybody. Share my screen. Okay. So let's look at what are the solutions within the Zenon platform for building management systems. So firstly, we can connect to any equipment of HVAC systems. So we're talking about building automation equipment, room controllers. So we have the variety of our drivers for different protocols. Most common in building automations are Modbus, KNX, BACnet, and so on. So while collecting data from your processes, you can also integrate data from external systems, like, for example, weather forecast, or you can use any of our process gateways, which are compliant with established protocols. So Zenon can be a Modbus slave, it can be an OpenSierra server. We can also enable a flexible project architecture, so you can have a horizontal or vertical project structure. And because Zenon is a configurable software, you can scale your projects very efficiently from technical perspective, or commercially, you can expand your existing software licenses and then buy only additional modules or pay the difference when you expand the license with additional tags. In terms of possibilities of making a good user interface, you can create your completely custom screens from a blank page, or you can use solutions from our wide library of prepared symbols and templates. We work very much on this so that we can enable you ergonomic and efficient design process. So integrated solutions like dynamic coloring of devices and pipes, world view option, and zooming, you can make a really user-friendly human-machine interface. And these solutions are all integrated and quite handy. In terms of system architecture, Zenon Network, which is our proprietary protocol system, enables you to have a performant and secure communication. You can have seamless or redundant or seamless or rated redundancy, static or HTML clients, so you can have a local and remote access. And IC 6131 compliant soft PLC is integrated part of Zenon platform and enables you to put additional process logic on your machine, or you can use it to recalculate and normalize raw data coming from your processes. And now we don't have enough time to cover all our local references. We'll just look at 5 of them. So first one is Zeta Gradnja, which is a construction company that built a large office building in Podgorica, Montenegro. This BMS system handles monitoring and control of HVAC systems, system generators, power meters, and so on. They have monthly reports for heating and cooling and electricity consumption. Also, machine learning model has been implemented. It's up and running, but still being fine-tuned. This video will be also published on YouTube channel, so you can freeze these screens and take a more detailed look. The second one is Okov. Okov is a chain of do-it-yourself stores. This BMS control system connects 7 retail warehouse locations in Montenegro and Serbia from one central location. 2 additional locations are being integrated as we speak. So also here a machine learning model was implemented. and integrated metering devices. Okay, let's go to look at the screenshots. And the last three are not so recent references anymore, but American School in Zagreb is the first one. Here you see a screenshot of the ground floor. You can click on any classroom, and then you get a more detailed window to configure parameters such as ventilation speed. You can see there are also CO2 sensors in each classroom, and you can set up the wanted temperature of the room and so on. And two additional screenshots from our projects in Varaždin. One is university, and the second one is student dormitory. In student dormitory, you also have exterior lighting control. Here at the bottom right, you can see a boiler room of the University North in Varaždin, and a boiler room in American School in Zagreb. Okay, this is just briefly given the time constraint about Zenon software and a couple of references. And now the most interesting part, I would like to invite Ognjen to join us and take over the screen and present us this use case from Montenegro.
Okay, thank you, Dan. Hello, everybody from my side as well. So, first of all, I would like to give a brief introduction about Elkon, the company where I'm coming from. So, let's move forward. Elkon has been founded in 2008, and since then we have a couple of major, we say checkpoints or breakpoints. So in 2010, we have done our first abroad project. In 2014, we have done our first BMS system. And in 2022, since the urge for the solar power plants has been in large demand here in Montenegro, we've also in 2022 started doing design phase, but mostly now we are oriented through SCADA systems for the solar power plants. And in 2025, we have launched first AI project on the systems that Dan mentioned, Zeta Granja and Okov. So in main points, our company has two large branches that we work on. So the first one is industrial automation, providing advanced solutions and for industrial processes. And the second one is BMS, or building automation systems. So for building management and smart systems for hotels, hospitals, building centers, and so on and so forth. So in order to do so, we, as a company, have all the necessary licenses, and we comply with all the necessary standards from the industry. So we can do all of this here locally, but as well in the world. Besides that, our engineers are constantly going to various of trainings with respective places and factories, so we can be up to date with the technologies that are currently in the world. So moving forward, our company has around 12 engineers that are constantly working, and we are split into a couple of teams. So the first is the design team that we work on our projects, the software team, and the site team that is there for our commissioning, maintaining, training, and support, and etc. We have our own workshop with around 15 employees at it. Mainly, we do our own cabinets, and we do it for our own projects, but sometimes at requests, from our partners, we build electrical panels from them as well, but we are oriented to the automation cabinets mostly. In our workshop, we are doing testing. We're working on testing of the cabinets and as well as FATs when it's requested from our worldwide customers. This is just a simple picture of a panel inside, how we do it, and it shows that we are doing all the standards as EATs requested from the outside requirements, I mean the other countries as well, because in some countries the color codes are not the same, so we complied with all different standards around the world. But the best show of our work are our references, so I will go briefly through some of them, but on our website you can find much more references and much more details. So as I said, our company is going to industrial, the first branch, and first in Montenegro, since the industrial is not very big, mainly that is oriented to the water supply and wastewater companies. So this is just some of our references that have been done recently. So water supply for Bigova Bay near city of Kotor, golf courts in Luštica, and so on, not to read them all. Wastewater systems in Nikšić, Berane. We were part of the team for acceptance for technical documentation for the wastewater system in Podgorica that is currently undergoing now in the construction. Adjustable wear and inflatable dam in Dubai. SCADA system that is currently active, SCADA system for water supply of city Bar, and currently it's in phase 3. We finished phase 1 and 2, and water factory in city Berane. On the other hand, we are working together as a partners with company Metzol on research and development projects for improving technology processes in electrolysis facilities. So the goal is to reduce electrical consumption, eliminate the anode effect, and improve metal quality. First, this started as a research with them, since they're a research company, and we did a couple of pilot projects all around the world. And recently, we have done and finished our first commercial projects where we delivered 260 cabinets in Cameroon. Moving forward, Elkon is as well a partner with the UK company called Dirhoff, and together with them, we are doing automation for the adjustable wear and inflatable dams all around the world. We have a large amount of projects done with them. This is just some of them, and also with them, we were part of a research team on dam vibration and shapes that are monitoring in real time how the dams are, as you can see on these pictures, how they are shaped and the vibrations, which are very dangerous for these kind of dams, and it can damage their structure. So as you can see, Elkon is not only a regular company, but we are oriented through researches as well, and we're constantly improving our technologies. The other branch of our work, BMS systems, which is the biggest part of our work in Montenegro here. This is just a briefly show of some of the hotels that we have done. So, and I can say that today we're doing the biggest hotel complexes in Montenegro, some of which are Teuta, Celebic in China. You can find them online and you can see how big of projects they are, but you can as well find them on our website. Furthermore, we've done BMS systems on elementary school, administrative buildings, Football Association of Montenegro, administrative buildings, Zeta Gradnja, Business Center, MTEL, Shopping Mall, Budva, Tower Company, Normal, and some of the, let's say, more interesting buildings, couple of hospitals, hospital for lymphatic disease, for skin disease, first private hospital in Montenegro, Moj Lab, that we will talk in more details. Old Jail in Kotor, Fortress in Old Town Bar, Castle of King Nikola, and so on and so forth. So the main topic of today's webinars, first private hospital in Montenegro called MoiLab. Elkon has been in this project from the design phase, and we've done the design for the BMS and EMD for this project. After that, we were engaged in the construction phase as well. The supervisory management system has been based on Zenon, obviously, and provides real-time monitoring, management, and regulation of the building's thermotechnical systems. So why are we doing all of this? So according to the current researches, 40% of global energy consumption is oriented in buildings, out of which 75% of commercial buildings are energy inefficient. So there is a large market for these kind of systems. And out of the 10% of currently buildings use smart technologies. So there is a lot of work in this field. When we are talking about hospitals, there is additional problems than this. So the additional challenges are positive pressure in operating rooms. It needs to be maintained, controlled sub-pressure in laboratories so the disease doesn't spread around. Isolation room, contamination prevents between different zones inside the hospital, precise monitoring regulation, humidity stability in different areas of the hospital, HEPA, air filtration, obviously, and air quality monitoring. The BMS plays a crucial role in hospital because all of this needs to run 24/7 without any kind of problems, any kind of glitches. So hospitals are among the most energy-intensive commercial buildings. HVAC systems represent a very large share of these buildings and very large consumption. And since the hospital has strict air quality and pressure requirements, the monitoring of these systems is very, very crucial. So what were our tasks in this project specific? Obviously, heating, substation, control and monitoring, domestic hot water, monitoring and controlling of 9 air handling units, maintaining positive pressure inside operating rooms, surgical blocks, and so on. Negative pressure in labs, strict staircase and elevator shaft pressurization, fire damper monitoring, humidity control, strict temperature regulation in critical areas such as ORs, NICUs, and ICUs, integration of all FanCoils, electrical generators, UPSs, lighting control of corridors and external building lighting. And obviously, all of this needs to be monitored through local HMI panels and through the SCADA system, or BMS system, which is in this case Zenon. Reporting and logging are key factor in this project, and I will save that for the very end. And also, we had email notification with the alarms. So this is the structure of the our project. On the top, we have Zenon BMS. We have 8 control cabinets, which are divided in the building. We have 3 third-party HMI panels that are located in operating rooms, and we have 10 of our J-Mobile XR panels that are located through the building, some of which are located on the nursing stations, and some of them are located in inside the rooms, such as intensive care and so on. So I choose to present you this project through our pictures of the BMS itself. So on the first slide, we can see the floor layout that we have done. So we decided to work with the 3D layouts. And on the top, you can see all of the systems that are in the building. So heating, water, heating substation, air handling units, UPSs, generators, and shortcuts to all the floor layouts. The big and crucial thing in this project is actually authorization. because it's a very strict policies who can adjust some of the temperatures and in which particular rooms because of the strict condition due to medical requirements. On the other hand, going back to the floor layout, on the floor layout, we were making small symbols from every element that is located in that room, and pressing on the symbol, you get a pop-up with the appropriate equipment that is installed in the room. Heating, substation, and domestic hot water, obviously Legionella monitoring and control and reporting has been implemented. Monitoring and reporting of all temperature and pressure values that have been installed. Monitoring and reporting of alarms for all pumps, motorized valves, electrical heaters, heat pumps, etc. And automatic pump alternation for the circulating pumps for the hot and cold water. On the other hand, automated Legionella has been scheduled, and they can also turn it on and off manually. Air handling units, besides regular air handling units that are working in any BMS, these ones are a bit more interesting because they need to adjust to the real-time situation inside the hospital. What I mean by this, inside the hospital, the air volume and pressure of the air is constantly changed inside the rooms, which we will see in the next slide. So these air handling units needs to adjust at the real time what is happening in the hospital and make sure that in critical areas of the hospital are provided with enough air and pressure. So, as I said, inside the hospital, especially inside operating rooms and ICUs, the very big and crucial factor is pressure inside the room. The pressure is affected by the gaps around the door, ceiling, walls, number of occupants in the room, medical equipment that is currently in operation, and frequent door opening and closing. So in order to achieve a stable pressure, real-time pressure monitoring is required, dynamic VAV control in order to achieve the pressure, and continuous airflow adjustments had to be made to achieve stable positive room pressure. Besides that, obviously, inside these kind of rooms, temperature control is absolutely mandatory, and the humidity control as well. And for the last but not least, why this project is so interesting to me, beside the regular trends and reports that have been done, like in every BMS, the medical staff actually asked from us to interact with this BMS in a way they can export these reports once the operation is done, so they can present these values to the with the medical documentation and everything as a proof that the patient was in absolutely best possible safety environment during the operation. And that would be briefly our presentation. So we will go to the Q&A session, and I will give back Dalibor the word. Thank you all.
Thank you, Ognian, for bringing this amazing project to public light, let's say. And now, let's see the Q&A session. Please post your questions. Yep, there are a couple of questions already, but please post the questions in Q&A so we can check them and take care. So, yeah, maybe always the most interesting question is, how long did the BMS project took to complete? Yeah, Ognian, I think you're the perfect one to answer.
Yeah, actually, it wasn't so long because at the 11th of November, the cabinets were delivered to the site, and the 1st of February, the hospital was running, and it was commissioned. So quite short period of time, everything was done. It was a crazy schedule, but at the end, we managed to do it.
Yeah, that's nice. So that's a little bit more than 2 months.
Yeah, including the breaks, the
Oh yeah, the
holidays
new
and
year.
everything. So 2 months.
Yeah, nice. What were the biggest challenges in this project?
The biggest challenges in these projects were actually the guys who are working in this industry know that we as automation guys, we need to communicate between all of the phases, including HVAC guys. And this time in hospital, we actually had to work with the construction guys because they couldn't understand that so small gaps inside operating rooms can have huge problems for us. For example, we had to duct tape the whole ceiling of operating rooms to prove that those millimeters gaps in the ceilings can affect our system. So communicating with all of the phases was the biggest challenge.
Good point. There is another question. What equipment was used in the automation cabinets?
So in the automation cabinets, we have used Shock Technic for the low voltage equipment and Schneider PLCs. Currently, there is 15 Schneider PLCs inside 8 cabinets divided through the systems.
Nice. Okay. Are there any additional question? Please put them in
Yes,
Q&A.
Dalibor, I think we have one in the Q&A. So do you have any representative company in Albania? So we Exoreti are covering Albania from Ljubljana. So I think, Dalibor, we do have at the end our contact information, right?
Yes,
The gentleman can contact me directly, and then we can see how we can help.
Yeah, of course. So in the Balkan region, please contact us directly. And if we are not there directly, we can help you anyway. Yeah. And yeah, what zenon licenses were used this project? Probably the structure, or how many licenses? Or
Yeah, so in this project, we have used supervisory 4K tags as a base. We use Modbus TCP driver. We had message control license as well. And correct me, Dalibor, for the name of the license, Server Pro client, sorry, till I remember.
the web.
Yeah, for the remote access, yeah.
Yeah, so 4,000 tags.
4,000, yes.
Yeah, nice. Okay. I think I don't see. Oh, there are. Oh, now the questions are coming. Did you have any projects with redundancy SCADA? Maybe I can answer this. It's pretty straightforward answer. Yes, then fully support redundancy. There is also circular redundancy. We have a couple of projects in our region. For more information, let's get in touch, and we can share the references and the structure of Xenon in more details. Can you integrate your system with Luxon mini server? It depends on which communication protocol is used. Mini server.
Yes, Dalibor, I also tried to now Google it. And
Yeah, okay.
Yes, so this is a controller, central controller used, as I see, in Luxon smart home built-in automation system. Basically, if you have a possibility to exchange data through any industrial common protocol, we can integrate it, of course. If this equipment enables Modbus, KNX, BACnet, we can establish communication and then integrate
OPC maybe.
OPC, yes, of
Thunder
course.
gateway. Yeah.
In process industry also, yes.
Okay. Yeah, thanks for nice words.
And we have one more. What was main reason to choose Xenon over other SCADA in this case?
A nice, tricky question, but simple.
But simple and yet. So basically, while we always choose Xenon over the other in the SCADA platforms, is the variety and of drivers and how easy it is to use them. For example, now if we have Modbus, we can take only Modbus. But tomorrow, if we need BACnet, if we need KNX, if we need everything, any other driver, we can have them there all available and easy to use. So to me personally, as an engineer, that's a big plus why we are going to the Xenon platform.
And nicely said. The Xenon is basically unlimited in every way, so it can extend the number of tags, it can extend the number of modules, and connecting to different systems. Architecture also is pretty can be pretty complex. Redundancy, as we mentioned, clients, different kind of clients, HTML, web clients, local clients. It's really a lot of possibilities. And thanks for the question, and thanks for the answer directly from the field. Any other questions? No, I think that's it. Okay, if you have any additional question, please let us know. There will be our emails. You also can Google all the companies at the end. I just wanted to mention that this webinar and all our previous webinars are recorded, and it will be published in our YouTube channel in a couple of days, probably. You can see our YouTube channel with all webinar recordings. A lot of tutorials, tips and tricks, and use cases are also there, so you can check it. And okay, that's it. Before we end, I just wanted to say that there will be a questionnaire at the end. When you sign out from the webinar, there will be a questionnaire. Please fill it in. It means a lot to us to get a direct feedback. And if you have any question, please contact us through our emails. There is also contact from Elkon, who can support you not just in Montenegro, as they mentioned, throughout the whole world and in different kind of projects in all kind of industries, energy and infrastructure. We'll be pleased to help you. Thank you for joining us, and see you in some of our next webinars pretty soon. Thank you.
Thank you, everybody. Thank you, Dalibor, for this opportunity, and I'll talk to you soon.
Thanks.
Bye-bye.